Toby from Predicate, which is an IT consultancy in Bonn in Germany. And today I'm going to talk about practical API security. So yeah, just a little bit information about myself. And what I wanted to talk about today is the OWASP API top 10 security risks. And when I did the talk with the live audience, I asked them whether they actually know that there is an OWASP API version. And scaringly, few people actually said that they knew about that. So my suggestion would be that if you're a developer, if you're an architect, if you are responsible for security, and you have to do with APIs, I would suggest that you go up and read on the OWASP list. Now, what is actually the OWASP list? The OWASP is a non-profit organization based in the US, and that every few years they publish a list of top 10 security risks. Now, what does that mean? The difficult thing is, and thank you to Jeremy who pointed that out after the talk, the list, of course, is not complete. Yeah, it's just the top 10 security risks. These are categories of security problems that your APIs might or might not have. So, but it's very helpful because the OWASP sits together every few years and decides which goes up and which is going down. So they just, based on their experience, decide which security problems are now more urgent than in the last few years. And the last edition was from 2017, so it changed a little bit in between. The categories got reworded a little bit, but overall it improved. But it also changed, interestingly, a little bit in the focus on what actually is the problem or what are the most common problems in today's IT security regarding to APIs. Now, these categories are just very broad categories, and when you go read up on them, it's a little bit hard to understand because they are very abstract, because they are categories. So what I'm going to do in this talk is talk with you about very concrete examples, and we don't have the time to go over all 10 of them, but we'll just pick out a few, and so you'll get an idea on what they might be about. And what I wanted to present to you today is how, at least I'm thinking about these categories, because based on who you are, which role you have in your organization, it can be a very different, it can have a different outcome for you on what to do about them. So let's get started. I'm using the Juice Shop by Björn Kimmenich. He developed a sample web shop which has a lot of security bugs in it. It's designed that way, so it's a help. On the other hand, it's almost a game, and be careful because it can get addictive. Every time you find a security problem, you're hitting a goal, and if you have hit the first few goals, you're always encouraged basically to go further. So if you look at that, please ensure that you have enough free time afterwards to catch up on all the rest. So I already, the Juice Shop is open source. You can find the source code on GitHub. What I did here, I already started it locally based on its Docker image. And so it's running locally, and I can access the Juice Shop in my web browser. Localhost 3000. All right. So that is the Juice Shop. Of course, nothing happens if I order anything there, and nothing is transmitted to the internet, I think, at least. It's just a single page application talking to a backend, which is also running on my laptop in this case. So what are we going to do here? Well, we don't have an account. Yeah, to order something, we have to create an account. So let's go, login. Well, I don't have a login yet. So what am I going to do? I click on not yet a customer. So I'm putting my email in there and a stupidly simple password in this case, just for the demo. And security question, well, I'm not interested in that for the demo, so I'm just going to put blah, blah, blah there. So before I now click register, I'm hitting F12. And this way, when I go to network, I can see what is transmitted from the web page to its backend. And now let me click on register. Now, here you can already see a thing, and which might be interesting because I just clicked register once, and basically twice information was transmitted. So you could ask yourself, well, why are there even 2 requests being made? And that might already be a hint to one more security problem. Actually, I don't know. I haven't investigated that one. So we'll just focus on the first request, but this is the kind of thinking that you basically gets you started very quickly on hitting other goals. So let us focus on the first request there, and let's see what is being transmitted, and let's enlarge that here. Oh, yeah. So this information here is basically what I entered, so no surprise there that it was actually transmitted. Now, with the security question, that is actually interesting because I selected the first security question from the list, so ID 1 is transmitted. Yeah, that makes sense. But the other thing that actually the text is also submitted and updated that and created that are also sent back to the server doesn't really make sense. And that might also give you a hint to some other security problem. Again, I haven't investigated that one. So let's have a look at what is coming back from the server. Now, what do you expect to come back when you click register? Well, of course, you expect to see whether it worked or whether it didn't. So, okay, here we have status success. So we were registered. That's great. But there's also the data block. What is actually inside the data block? There's, for example, an ID. And we could say, okay, yeah, we got a user ID back from the server. That could make sense, and depending on what your shop is about or what the next requests will be. But actually, now that it's 22, I'm already thinking, that maybe the shop only has 22 customers so far. So, and that might already, for some companies, be sensitive information to give out. They might want to hide how many customers they have. I mean, there was a discussion about back then when Twitter was bought. Well, how many customers do they actually have? Well, okay, in case of Twitter, they talked about monthly active users. But here we have the total user count, I guess. But that might be an information that you actually don't want to give out. So, but it might make sense at least to give out an ID of a user, maybe not a numeric increasing starting from 1. So what else do we have? And I asked this question to the audience, so I'll give you a little bit of time to think about that. What else is interesting in there, which you're thinking, why is that even in there? Yeah, and so the live answers which came back from the audience, well, there is an empty username. What is that even about? And I agree, that is also interesting. Why is that even there? But also what came back from the audience is, why is the role customer coming back? And that is interesting. So let's see how we can exploit the role customer. What I'm going to do now is to take the first request and copy it to the clipboard. Now, I do that by going to the context menu and copy value and copy as curl, POSIX in my case. And I'm just going to paste that in some editor. Now, that is everything which is being sent from the website to the backend. And we're going to modify it. First of all, I'm going to modify the email address of the account that should be created. I'm going to modify it to say admin at predicate.de, well, that won't change anything basically, except the new user will have a different email address. But what I'm going to do is I'm also going to add role, and I'm going to say admin in there. And let's just see whether that works actually. And so what I'm going to do is copy it to clipboard again, and I'm going to close that one here and going to a shell. That's a POSIX shell on Windows in my case. The POSIX just makes the format a little bit easier to read. So that is just the git bash. And I can copy paste that in there and execute it. And you're seeing the fireworks in the background, which means we hit the next goal in the shop, and we successfully created an admin user. And again, in the response, in the HTTP response, of course, you can also see success. So that is basically our first security problem within the shop. So what did we actually see? Well, first of all, you could say we saw number 8, a security misconfiguration, because we saw that there is a field called role. And the question would be, well, during registration of a new user, why did the user to know that it has the customer role? Yeah, the application could know that if an anonymous user comes in, or a user of the web page, and registers him or herself, that it will have the customer role always. If it gets the admin role, as in my second case, something is wrong actually, right? So why was the role actually transmitted back to the client? You could say that is number 8, that the role field is actually in there. And of course, when creating the admin user, we reused the role field and actually set it during registration. That is number 3, a broken object property level authorization, because we were able to set the role field to admin, although we shouldn't have the permission to do so. Yeah, that is basically that. Now, that is just, again, how it worked. I showed you that. Now, why was that even the case? Why was the role field even in the request? And so usually what happens is developers are lazy. Developers design the schema of the database, and they usually do that by writing, for example, in Java, they could write an entity class. The juice shop is not actually using Java, but in this demo, we can just think it would be Java. And so if the programmer would use Java, he might, or she might write a person class representing the person table in the database with these 6 columns. And there might be a role column in the database, of course, because we need to store roles somehow. And so we'll write it in there, and then the database automatically gets created out of that class. And the schema is created out of that class. And so since we have that class, we have just reused it in the logic layer of our application and handed it up to the API layer of our application. And boom, that's what we got, because now the role was actually returned to the user. And that is how the bug actually could have gotten in there. Now, what is the fix? The fix in this special case, of course, would be, for example, to create a second class. Here it's called data DTO, which is short for data transfer object, so the object which is going over the wire. And we have restricted the big entity to just the one field ID, because we said, okay, the single web page application might need to know the user's ID. And so you have to copy it. There are frameworks for that. You can use them. I mean, copying code manually is a little bit tedious, but it's possible to use or to use libraries for that. But the resolution of the problem would be to use a second class and to copy the data over and use the second class to expose it in the API. Now, But that fix here is already basically restricting our thinking a little bit. And because the interesting part is that in these security categories, in the OWASP categories, what you can think of, well, there are different solutions for the same problem. And what we now discussed here is the solution for when I'm the developer for the specific service we are talking about. Yeah, then I can change the source code, and that I would change the source code in the way I just described. The thing is, if I'm responsible for security in our organization, and there are like 100 services out there, 1,000 services, or even more, it might for myself be very difficult to go ensure that all the developers of these services actually apply that fix. So the question then becomes, well, how can I ensure that all the developers out there are doing the correct thing? And so the answer is a little bit different in this case. Of course, I could start training the developers. That is always a good idea. But the question becomes, well, how can I ensure that in the case I just described, they just don't make this one mistake, right? And so the question then becomes, well, we have different tools in our toolkit. And so we just pull another one out. And what I'm showing you now is an API gateway. The API gateway sits in front of our service. So think of the juice shop of being the yellow box back there. And my browser set somewhere on the public internet. Yeah, in practice, everything ran on my laptop, but that's fine. So we're putting the API gateway between them. Okay. Well, that alone doesn't help anything. So what are we going to do? The thing is, we are going to use an OpenAI specification, which is basically a technical description of what is being sent from the browser back to the service. In general, you can also say what is being sent from microservice A to microservice B, or from company A to company B. There might be different use cases for that. I'm just going to stick with the browser here because that is what I demoed. So what is described in this Open API is exactly the format of what is being sent there and what is being sent back. Now I take that, and you can see the path here. Yeah, you can see what was being transmitted as the body towards the server, and you can see that actually there is no role field here because on a good request, no role field should be sent to the server, because we saw in that case it's not an admin user which gets created, but a normal user. So we're taking the Open API, we're putting it onto the API gateway, and I'm demoing here because we are developing that. I know it best, of course, an open source API gateway ourselves. You can just go download it from its GitHub page, and it requires Java to run, and you can just extract that to that directory here, and I'm going to start that. And what that does, I previously, before the demo, I just adjusted the configuration to these 3 lines. So what that does, it tells the gateway to open port 2000, and then use the Open API schema to validate the requests. And that's basically it. So now that I started the gateway, I'm going to change my request here. Let me do that over there to 2000, because usually, as I showed in the PowerPoint diagram, the gateway sits between what is coming in from the internet, and the network ensures that everything has to hit the gateway. It cannot hit the backend directly. And when the gateway receives something, it's going to forward it to the gateway, to the actual service backend there. So, and you put firewalls in place to ensure that. So I'm going to copy that and execute that. Actually, I have to change the email again. So I'm going to do admin2 in this case. because we would create another user, and I'm going to execute that. So what is going on there? The gateway gave us an error because the role property was actually present in there. And so that is the thing. If I remove the role property, then we are actually back to a normal user, and I execute that. The gateway will let us pass through, and we will get a success. So we registered another user, but a normal user. So that is the effect of the role field not being present in this object. Now, when you put these Open API YAMLs onto the gateway, you have to create a process about that. And it might be that you create a Git repository, which is owned by the security team. The developer of the backend application can create a pull request on that Git repository, but the pull request has to be reviewed, and that is important, by the security people. The pull request, I mean, you have to ensure that it's of good quality. It doesn't make sense if the developer adds role here, yeah, we are back to square one. Yeah. You really have to ensure that it makes sense. There are some automatic checks which you can do. For example, this additional property is false here is the common pitfall that you might have. So you might have automatic checks, but you usually, as with a role field here, you also have to do manual checks on that. And then you can deploy them to the gateway, and then hopefully you're better positioned towards security than before. Okay, so I see I'm a little bit short on time here, so let me catch up on that. So what the Open API does, it's restricting what can be contained in the JSON, which is either sent to the server or, and that is also very important, which is coming back, because we saw that it's still the role field is coming back, so the attacker knows, oh, there is a role field in there. So how can we restrict that? Well, of course, we cannot really do that with, well, we could do it within the gateway. That then becomes tricky. But we could say, well, the developer shouldn't have the role field in the response. And actually, if you look at the response I have modeled here, I don't actually have a role field in there. So why is the gateway letting it through? The reason is that most gateways, as is the case with Membrane API gateway here, have a validate response set to no by default. So if I activate that one, and I'm changing the email address again and executing it, then that is going to be blocked, but the response is going to be blocked. Now be careful. This request actually created a user on the backend, but the front end doesn't know about it because the gateway just cut off the response being transmitted. Instead, it replaced it with this error response because there was a data block present, but the data block wasn't modeled in the Open API. So, and that would fix the category 8. Yeah, the first thing, you actually using a gateway, using the Open API, not with the role field present, would fix the category 2 issue. The other one, validating the response, would have improved our situation in the category 8. Of course, in this case, it's not really solved because now the application doesn't work anymore. Yeah, the backend developer has to do some work and remove the role field, but that's a different issue. At least you have a process within your organization where you're reviewing that stuff. Okay, so what did we learn? Well, use a DTO, that is the developer fix, and the general, if you're responsible for more than one application, go do validation and also think about the response. And of course, actually test whether the gateway works if it's configured correctly, because otherwise it will get very tricky. Okay, so the second demo I wanted to show is broken authentication. And let me actually cut that. Okay, so now I know that my colleague has a user and I want to hack him. I know his email address, but actually I don't know his password. So what am I going to do? I'm going to click on forgot your password. I'm entering his email address here. And the security question in his case is mother's birth date. Now, he is 51 years old. So he's born in 1972. So how old is his mother? I don't know, maybe 1945 or something. So let's put just 1945 in there, and then just set ABC123, ABC123. Okay. Well, turns out his mother is not born on the 1st of July of 1945. What we can do is we can use a Python script, which I wrote, which just iterates over all possible birth dates in this range from 1945 to 1969. So I'm just guessing here, and which tries to repeat what I just did in the browser and does that by script. So let me actually execute that one here. And it's much faster than executing it by hand in the browser. But it turns out that actually after 100 requests, we get limited. The backend starts returning too many requests. So how does that work? Well, the backend has a limit that every user can make 100 calls in a 5-minute interval. So the question then is, well, how does the backend, which is basically the gray box back there, how does the backend identify individual users to enforce their limit? Because if the first user has already exceeded its quota and has done 100 requests, the second user should still be able to use the backend. How get user identified? And the single way to be identified, because we are not logged in yet, and that is important, is basically to use the user's IP. And the IP address, the backend sees connecting to it is actually, in our case, what is shown here on the PowerPoint would be the 10.007. So the service backend would just limit the 10.007, and so that wouldn't make sense. So what do we do about it? Well, most API gateways use a header called x_forwarded_for, which gets inserted in the API gateway. And the API gateway inserts the address, or the web application firewall maybe, inserts the IP address of the actual user, so that the service backend can actually then go track the IP address and count per IP, well, how many calls have yet been made within the last 5 minutes. So the problem then becomes that, well, what is the format of this x_forwarded_for header? Well, actually, it's a list of IP addresses, because there might be multiple gateways in the chain. And so every gateway in the chain might add the IP address from the previous connector to this list. So it's a comma-separated list of IP addresses. The IP addresses can be IPv4 or IPv6. And the ugly thing is, IPv6 addresses are very hard to parse. So actually, most software systems don't parse them at all. So what are we going to do in our case? Well, we are going to add a header, and we are saying, well, we are saying there's just another fake gateway sitting in front of us, and that then received the date the mother was born on, which doesn't make sense because it's not an IP address, but it's still sent to the backend. And I'm going to start that. So what is happening now? The backend service is counting requests per user. And for every date we are trying, the backend thinks we are a different user, and so it's allowing the request. And you can already see we are above 100. And shortly, we'll have the correct response. And so the question becomes, well, what are you going to do about that? Here we go. Yeah. Now I have reset his password. What are we going to do about that now? And the answer, of course, is to block the, so that is what happened. Basically, the date was appended. And so for every date, the backend just counted a 1. So what would have to happen in the first component that runs on your infrastructure, facing the bad public internet, you should remove the X-forwarded 4 header. And in our case, I just sent it directly to the backend containing the fake data. Yeah, so that's just broken authentication. But the thing is actually, and that was a question from the live audience, well, if you have a limit of 100 within 5 minutes, does that even limit you enough not to guess the birth date? And of course, it doesn't, because 100 in 5 minutes equals to 28,800 in 24 hours, so within a day. Now, if you think about it, his mother's possible birth dates might be within 10 years, might be around 36,000 possibilities. And so within 1.5 days, you could ensure that his account was hacked. So that doesn't resolve your problem. So what you would have to introduce is different limits for different endpoints. And the security people should think about that. And here we are at a level of discussion when I talk to customers, which we are not at yet. The most security people are very happy basically when they can check off their Excel checklists and say, well, we have thought about something or we have bought something. But through this level discussion, actually, unfortunately, in my opinion, it rarely gets down to. Yeah. So what can you do with this list? Well, please go read up on this OWASP API Security Top 10 list. I have created this table, which might be helpful for your organization, which might be a starting point for your organization to think about these risks. So these are the top 10 risk categories again. This is maybe what you could do about them. This is actually in which component you would have to do something about it if you were to automate it. But be careful, using a tool might not be the only thing. You might also have to change some organizational structure or how you do things in your organization. The responsibility column here says, well, which team might do something about that category of security problems. But the one thing to take away from this talk is, for example, the last thing we talked about, broken authentication. Now, if you're in your organization are saying development and operations and the security team are all together responsible for fixing this category, you basically have the best recipe for setting you up for failure, because responsibility should usually only be in one hand, and they should have the power to tell the other ones on what to do or what not to do. So depending on how your organization is structured, you in each category, you should always appoint a lead team, which is actually responsible for doing the main work there. Of course, this category, again, is not complete. Yeah, there might be other security problems out there. These are just the top 10 the OWASP people have thought about this year. Yeah, so that is the main takeaway. I hope it helps for you to better improve the security situation in your app. And yeah, to think about these things, it helps to think like the attacker. And again, security, as you can see, because the OWASP list was revised after now 6 years, I think, or was it 29? Then it was 4 years, I think, 19. So it's revised every few years. So it's an ongoing process where you have to re-evaluate whether you're still up to the game. And the thing is, just paying for an API gateway doesn't make you any safer, because you actually need to use it correctly. And that's it. We have a YouTube channel, but that's unfortunately in German, so it might not help you that much. But here are the resources, and thanks for your attention. Yeah, if you want to get in touch, here are my contact details. Thank you.